Hi kids, now we will be going with this paper 1 discussion. You can look into the first question. The first question says, the figure shows a loop made of piece of copper wire. The shape of the loop is two concentric semicircles and two connecting straight line segments. The loop is on horizontal tabletop, but initially the smaller semicircle is in vertical position. The smaller semicircle is turned into horizontal position in 1 second. The dashed line is the axis of rotation, so it is rotated this way. Initially it was like this, then later on it was rotated like this. The whole loop is in uniform vertically upward magnetic field. The magnetic induction and the resistance of the loop and the radius of the smaller circle are given, so you need to find average value of induced EMF. So that's the first question. So what is going to happen when it was in this situation? There is bigger loop like this and smaller loop like this, and magnetic field is in the upward direction. So flux through this region is 0, flux through this region is magnetic field into this bigger area. Now when you do this situation, when you put like smaller loop on the bigger loop, then what is going to the effective area? Effective area is going to become bigger area minus smaller area. It's only this much area, right? That is bigger area minus smaller area. So what is happening to the flux? What is happening to the area affected by the flux? It is decreasing. So what will happen to the flux? Flux will decrease. So flux is decreasing. If the flux is decreasing, when you are observing from the top, what will happen? Like the current will try to create some flux in that direction, right? Flux is decreasing. Initially flux is more, later on flux is less. So induced current will try to create some flux in this direction. That's by, you can go by energy conservation, that is Lenz's law, right? So if flux has to be created in this direction, then the current has to flow like this, right? Like this. So that is when you are looking from the top, current in the bigger loop is in anti-clockwise. Current in the bigger loop is in anti-clockwise, right? Current in the direction of induced current in the bigger loop, while the smaller loop turns is anti-clockwise as seen from the above the loop. When you are looking from above the loop, the flux is decreasing. So if the flux is decreasing, then the induced current will try to create some flux in this direction. For that, the current has to flow this way. So that is in the bigger loop it is anti-clockwise, in the smaller loop it is clockwise. So from there you will be getting option B as correct, option C as wrong. Now going to the first option, the average value of induced EMF. How to calculate the average value? That is change in flux by time taken, right? So how to calculate average value of induced EMF? That is change in flux by time taken. Now how to calculate change in flux? That is magnetic field times of change in area. What is change in area? Change in area is initially bigger area is affected, finally bigger area minus smaller area is affected. If you look at the difference in the area, that is the smaller area, right? So magnetic flux change is going to be magnetic field into change in area. Change in area is how much? Area of that smaller loop, pi r square by 2. So this will give you change in flux. Change in flux by time taken will give you average EMF. So when you substitute the values, you will be getting almost 0.022 volts, right? Thereafter, the last question is the greatest value of induced current if the smaller semicircle is rotated at a constant angular speed and it takes exactly 1 second to turn from vertical position to horizontal position. So it is rotated with a constant angular velocity. Now they are asking what is the instantaneous induced EMF. How to find instantaneous induced EMF? We need to see what is the rate of change of flux at any instant. Now when you look at this situation, the flux because of this bigger loop is going to remain constant. The flux because of the smaller loop is going to change. So we need to find only change. So I can look into only flux through the smaller loop. So flux through smaller loop at any instant change is going to be, so B bar dot A bar, right? B into A into cos omega t, where omega t is the angle between area vector and magnetic field, right? Anyway, here it is going to be sin omega t. Anyway, that doesn't matter because they are asking only about maximum value. So this is the instantaneous value of induced EMF. Now maximum value will turn out to be this much, right? Maximum value will turn out to be this much. Now you need to substitute the values. Maximum value. They are asking current maximum. So current has to be maximum, then the induced EMF has to be maximum. So induced EMF by resistance. So that will give you the answer. Now this is the same principle what we will be using in AC generator, right? That's like we will be keeping a loop in a magnetic field and we will be rotating it. So then what will happen to the flux? Flux will be varying with time, or induced EMF will be sinusoidally varying with time. So we will be getting AC source. So if you want to make a AC source, keep a loop in magnetic field and rotate it, right? Going to the next question, two soap bubbles of radius R1 and R2 are joined by a straw as shown in figure 1. Air flows from one bubble to other bubble, and a single bubble of radius R3 remains finally, and a film of soap solution is present at the right end. choose the correct statements. So under isothermal conditions, you need to find what is the surface tension. Thereafter, they are asking what about the radius of curvature. Okay, we'll see that. Under isothermal conditions, so temperature is remaining same. So initially what I can say, this pressure into this volume equals to number of moles here into R into T. PV equals to nRT for this one, PV equals to nRT for this one. Now similarly, finally I can say total number of moles are available here only. So finally P3 V3 equals to total number of moles there, that is N1 plus N2 into R into T. But what about the pressure? Inside pressure minus outside pressure is 2T by, I mean it's soap solution, right? So there will be two interfaces, so 4T by R. So inside pressure will be outside pressure plus 4T by R, outside pressure plus 4T by R1. So here inside pressure will be outside pressure plus 4T by R2. Here inside pressure will be outside pressure plus 4T by R3. So when I substitute that, I will be getting some equation. Now what is the thing? I can equate, yeah, I can add these two, right? N1 plus N2 RT. So when I add these two, on the right hand side I will be getting N1 plus N2 into RT, which is same as this one, right? So I can say this P0 plus 4T by R1 into V1 plus P0 by 4T by R2 into V2, that must be equals to P0 by 4T by R3 into V3. So that's the first term. Okay, so this is equals to this plus this. So after that you just need to manipulate it, then you will be getting surface tension value, which will be option A. Now what about the other options? They are talking about final radius of curvature of soap film at the right end. At the right end, will it be same as R3 or less than R3 or more than R3? Now see, now if the radius is less, then what is going to happen? Oh, pressure inside minus pressure outside is 4T by R. So less the radius of curvature, more will be the pressure. P0 plus inside pressure will be outside pressure plus 4T by R, right? So the less is the radius of curvature, more will the pressure inside it. More pressure inside it and less pressure here, what is going to happen? Air will flow like this. That is the reason this bubble is increasing in size. Right? Now if this radius of curvature is not R3, then the pressure here is not going to be same as this one. If the pressure here is not same as this one, then what will happen? Then air will start flowing, but right now it stopped flowing, right? So both radius of curvature must be same. Only then the pressures will be same, only then the flow of air will be stopped. So both will be same radius of curvature. Going to the next question, when an object O moves towards a fixed silver lens as shown in figure, select the choices. So now you know this will act like a concave mirror, right? In case of concave mirror, whatever happens, the same thing will happen here also. So I mean all the possibilities will be there in concave mirror, but in convex mirror, like there will be only some possibilities, but in concave mirror all the possibilities will be there. Going to the first option, they are saying like image may move towards negative x-axis. Second option is speed of image and object may be same. Image may move faster than object, image may move towards the arrangement. See, now this is how you will be finding where the image will be formed. I mean when you differentiate it, you will be getting that's how at what rate the image is moving, right? Now V by U can be 1, greater than 1, less than 1. That you people know already. Like if you look at the table, like V by U can be greater than 1, less than 1, and image can move towards or away. All the possibilities will be there in case of concave mirror, right? So anything can be possible there. Next question goes like Young's modulus of uniform cross section rod Y is AX plus B, where A and B are positive constants. Two equal and opposite forces F are applied at the two ends of the rod. So what is going to be the net force? Net force is 0. So if you take any part, if you draw the FBD of this part, that part must be also in equilibrium. So what will be the surface tension? I mean what will be the force here, internal force? That is going to be F. So if you want to define Young's modulus, you need to know what is that force. That force is F everywhere. No matter which cross section you will write, the force is going to be F only because it is in equilibrium. Now stress is the restoring force by area. The restoring force is F everywhere. So stress is going to remain same everywhere. Stress is same throughout the rod. But what about strain? Strain is defined as, Young's modulus is defined as stress by strain. Now strain will be stress by Young's modulus. So it is not going to be same. Strain is linearly varying. No, I think it is like 1 by AX plus B form, right? Product of Young's modulus and strain. Product of Young's modulus and strain will give you stress. Stress is remaining constant throughout the rod. Yes. So we'll be getting option A and option D as correct, right? Yeah. Everything we can get from here. This is constant. Restoring force and area are constant. So stress is constant. So Young's modulus is varying linearly. So strain will be like when you take to the strain to the left hand side and Young's modulus to the right hand side, you will be getting strain is inversely proportional to Young's modulus, that is inversely proportional to Ax plus B form. Going to the next question, a thick shell of inner radius r and outer radius 3r has a uniform charge density rho. It has spherical cavity of radius r as shown in the figure. Choose the correct options: field at O, field at O1 and field at P, then potential at O. So for all these questions, what we will be doing, we will be looking at the figure like, we will be looking at this figure like this bigger sphere minus this smaller sphere minus this smaller sphere. So if you want to find the field here, what you need to do, you need to find the field because of the bigger sphere and subtract the field because of the smaller sphere and subtract the field because of the smaller sphere. Now what I have done is, I have taken the charge of this one is q, charge of the smaller one is q. If the charge of the smaller one is q, charge of the bigger one is going to be 27q because the volume is going to be 27 times. If this charge is q, this charge will be q and this charge will be 27q, where q is how much? Density times 4 by 3 pi r cube. Now field because of this bigger sphere at the center is 0, field because of the smaller sphere at the center is 0, field because of this sphere at this point is going to be, now this point is going to be outside the sphere. So what I can do, I can visualize this centered charge. I can visualize this centered charge placed like a point charge at the center. So kq by this distance square, kq by this distance square, right? Anyway, that is not going to be 0. So option A is not correct. Now going to option B. Option B says at O1, that is at this point, right? So if you want to find the field there, what you need to do, you need to find the field because of this bigger sphere here. Now that bigger sphere from center, it is at a distance 2r. Now field inside the solid sphere is rho into distance from the center by 3 epsilon naught. That if you want, you can derive by Gauss law also. So rho into the distance from the center by 3 epsilon naught, that is the field because of the bigger sphere as it is inside. Now the same point is going to be outside this sphere, right? So k into q by distance 2r whole square, k into q by 2r whole square. Now that point is center of this sphere, right? So field because of this one is going to be 0. So when you do the calculation, you will be getting 7 by 12, which is option B. Now going to the next point, it is field at P. Field at P. P is where? P is here. So P is outside all the points, so the calculation is going to become much easy. P is outside this. So you can replace this entire thing with a point charge, kq by distance square. Now for this one also it is outside, so kq by distance square. For this one also it is outside, kq by the distance from the center is 2r whole square. So when you do that calculation, it will turn out to be option C is correct. Now going to option D, you can mark directly like option D is wrong because dimension wise it is not correct. But they are asking what is the potential. If you want to calculate the potential, that is potential because of bigger sphere at the center minus potential because of this sphere minus potential because of this sphere, right? For this sphere the point is outside, for this sphere the point is at the center, for this sphere the point is at the center. So at the center potential will be same as 3 by 2 times of 3 by 2 times of the surface, 3 by 2 times of the surface, for it is a solid sphere, right? So on the surface, what will be the potential? kq by r. So at the center it is 3 by 2 times. For this sphere also it is at the center, so that is 3 by 2 times of the surface. So 3 by 2 times of the surface. Now for this sphere it is outside. For this sphere the point is outside, so you can directly go with kq by distance. So when you do the calculation, it will turn out to be 23 by 6 rho r square by epsilon naught. If the dimension wise, if the option D was rho r square, then you would have got D as correct answer, right? Now the next question, an inductor and a resistance and 2 identical bulbs are connected to a battery through a switch as shown in the figure. The resistance of the coil having inductance L is also R. Now that's the important thing for the question. Inductance is also having resistance R. Which of the following statements correctly give the description of what's happening when the switch S is closed? Now, which bulb will light up early? Now when you close the switch, you can see like this, you can see like this circuit like separately and this circuit like separately, because the battery, the potential difference across this thing is V, the potential difference across this thing is V. Now what you can do is, you can see like this circuit separately and this circuit separately. If you see that, what is going to happen, this bulb, like immediately more current will be flowing through this bulb. Now what is that more current? That is, what is that maximum current? It is V by R plus R, R plus R. Now what about this case? When there is inductor, the current will slowly grow. The current will slowly grow and it will achieve maximum value. So it will achieve a maximum value. What is the maximum value? This resistance is R, this resistance is some other R. So current is going to be V by this resistance plus this resistance. So current in this circuit and in this circuit is going to remain same finally, but initially the current in this one will be more, current in this one will be less. So finally both bulbs will be glowing with the same intensity, but which will light more quickly, more bright and initially, that is this bulb. So bulb B2 lights up earlier than B1 and finally both the bulbs shine equally bright. It takes time for the current to grow, right? Going to the next question, a light glass tube with sealed lower end and cross section area contains a column of mercury and there is gas trapped here. The glass tube is sliding down a slope of inclining angle 30 degrees. The kinetic friction coefficient is given as root 3 by 6. The pressure of the gas trapped, you need to find what is the pressure of the gas trapped when compared to the atmospheric pressure. So this entire thing is sliding, right? So you can find what is the acceleration of this entire system. That acceleration is g sin theta minus mu g cos theta. I mean, the g sin theta will be because of weight and mu g cos theta will be because of friction, right? So from there you can get the acceleration of the system. Now if you look at only mercury, now its weight component is there, that is, mercury weight is given as 2 kg. So what will be its component? 2g sin theta. But if only 2g sin theta is there, then its acceleration will be g sin theta, right? But you know the acceleration is less than g sin theta. Why is that happening? That apart from its weight, there will be atmospheric pressure force pushing it this way. So weight component plus atmospheric pressure will be pushing it this way, but gas pressure will be pushing it in the opposite direction. So the net force along this direction must be equals to m into a. That is mg sin theta plus this atmospheric pressure force minus this gas force equals to total mass into acceleration along this direction, which is g by 4. And m value is given, g value, okay, you know, sin theta, atmospheric pressure, area of cross section is given. This you need to find. Area of cross section is given, mass is given, this acceleration we have found. So when you calculate it, you will be getting P as 1.2 times of atmospheric pressure. 1.2 times of atmospheric pressure. Atmospheric pressure is 10 power 5, right? In the next question, in the problem, the motion of small disc sliding along a horizontal frictionless surface, is investigated. A column having a square shape cross section emerges from the ice. The side of the square is 10 centimeter. The disc is attached to the column by means of a piece of 1 meter long string. The top view of the arrangement is shown. The disc is given an initial speed pi. How much time elapses until the disc hits the column? So what is going to happen? It's like you are giving a velocity like this. So it will be performing circular motion about this point. It will be performing circular motion. Till when? Till it hits this position. Once it hits this position, what is going to happen? It will perform circular motion about this point. So from here to here, like by the angle, till the angle is 90 degrees rotation. So the radius is 1 meter. But once it rotated by 90 degrees, what is going to happen? The radius is going to become only 0.9 meters. But the speed is going to remain same because tension is always perpendicular to the speed. So what is going to happen? You can see the radius of circular motion is going to reduce, but velocity is remaining same. So omega will be increasing. So omega equals to V by R, right? So R is reducing, so omega will be increasing. So from here to here omega will be less, from here to here omega will be little more. Now after this it will be performing circular motion about this, then omega will be even more. So what is the time taken to cover this 90 degrees? That is, you can use theta equal to omega into t plus half alpha t square. Anyway, alpha is 0. So t equals to theta by omega, that is pi by 2 by omega. T1 will be how much? Pi by 2 by omega 1. From here to here, what is the time taken? It is angle is pi by 2 and angular velocity is omega 1, let me say. So the time taken is pi by 2 by omega 1. Now in the second case, pi by 2 by omega 2, in the third case, pi by 3 by omega 3 and so on. Pi by 2 by omega 3, pi by 2 by omega 1, pi by 2 by omega 2, pi by 2 by omega 3 and so on. So when I calculate the total time, what I will be getting? Omega is, initially how much is the omega? V by 1. In the second case, V by 0.9. In the third case, V by 0.8. Right? So omega 1 I substituted V by 1. Omega 2 is V by 0.9 and so on. So when you add all this, you will be getting 5.5, and when you substitute the value of speed, you will be getting the required answer. The only thing you need to understand is it will be performing circular motion with varying radius for every 90 degrees. Two planks A and B of length 20 centimeter and 10 centimeter and mass 3 kg and 12 kg respectively are connected by a frictionless massless hinge as shown in the figure. Initially the system is at rest on frictionless surface. The plank falls clockwise, finally comes to rest on the top of plank. What is the displacement of the hinge just after the two planks comes into contact? So that's like initially this is the situation, this is 20 centimeter, this is 10 centimeter, this mass is 3 kg, this mass is 12 kg, I have put it at the center of mass. Now when it is falling, what is going to happen? The entire system is going to move backwards because center of mass must not move along a horizontal direction, because net force along horizontal direction is 0. If the net external force along horizontal direction is 0, center of mass must not move along a horizontal direction. So if it is falling this way, the entire system must be moving backwards. Right? Now anyway, if I look at it in parts, like if it is falling this way and the entire system is moving backwards, I will be looking at it like parts. So when it is falling this way, how much the center of mass will move forward? It's like, yeah, m1 x1, yeah, I can say like sigma m1 x1 must be, sigma mx must be 0, right? So I can look at it, it's a linear equation, so I can do it much easily. You can go by your own way, that's fine. So center of mass must not move along the horizontal direction. So what I will be doing, I am looking at m into x. So how much this mass has moved in the forward direction? It has moved 10 centimeter. So 3 into 0.1 movement in the forward direction. Now this entire thing is shifting backwards, that is 15 kg is shifting backwards by distance x. So 15 into x. But I know like sigma mx must be 0. So this is in the forward direction, this is in the backward direction, magnitude wise they must be equal. When I do that, I will be getting x equal to 0.02. A torch bulb rated 4.5 watt, 1.5 volt is connected to the, is connected as shown in the figure. To make the bulb glow at full intensity, what should be the EMF of the cell? So there are many things here, I will be just pointing it out step by step. Bulb rating is, bulb has to glow maximum, they said. So I can say like the potential difference across it will be 1.5 volt, which is given in the question. And power and voltage is given, so you can calculate what is the current flowing through the bulb also. Now if this potential difference is 1.5 volt, I can say this potential difference is also 1.5 volt, and this resistance is 1 ohm, so this current is going to be 1.5. If this is 3 ampere and this is 1.5, I can say this current is going to be 4.5 by KCL. Now if this current is anyway, this voltage is 0, so this voltage is also 0, this voltage is 1.5, so this voltage is also 1.5. Now this current is 4.5, so the potential difference across the resistance is going to be I into R. So 1.5 into 5, 7.5, and current will flow from higher potential to lower potential, so this potential has to be minus 7.5. So what is the potential difference across these two? It is going to be 9 volts. So what is going to the battery EMF? It is going to be 9 volt. The next question, a current carrying conductor is in the shape of an arc of circle of radius 1 meter subtending an angle theta at the center. If it was a circle, subtending an angle theta. A long current carrying wire is perpendicular to the plane of the arc and is at a distance 2r. That is, if you draw a circle, this will be at the other end. Okay. Joining points M and C. Okay. Current in the arc as well as straight wire is 2 ampere. Find the magnetic force on the arc. Now this is what they said. Now okay, current carrying wire is here. Now if you take some element here and find the force on that element, and if you take similar element here symmetrically, then you can see like magnetic field. Yeah, with respect to this one and radius 2r, I have drawn a circle because magnetic field will be tangential to that circle. So you can see here magnetic field is tangential, and that small element is going to be in this direction, Now if you want to find the force, it is L bar cross B bar, this force is going to be into. What about this? L bar cross B bar, this force is going to be out, this force is going to be into, this force is going to be out. So they will be cancelling each other. So for every element you will be having symmetrical elements, so those forces will be getting cancelled. So force is going to be 0, but not torque, because they are in the opposite direction, they will be rotating about this axis. In the figure, ammeter 1 reads 10 milliampere while the voltmeter reads potential difference of 3 volt. What does ammeter 2 read? The ammeters are identical and internal resistance of the battery is negligible. Consider all ammeters and voltmeters are non-ideal. The first thing is, I assumed this as 0 volt, so this is 4 volt, 0, 0, 4, 4. Now apart from this, what information is given? Ammeter 1 reads 10 milliampere, so this current is given 10 milliampere. So I know potential, okay, and nothing much I know. Voltmeter reads a potential difference of 3 volts. So if this is 4 volt, what is this going to be? This is going to be 1 volt. How I concluded this? Because they said voltmeter will read potential difference of 3 volt. So I know potential difference, I know current, so from there I can find the ammeter's resistance. Now if I know ammeter's resistance, I can use the same value here also. Right? Now if you look at this part, it looks like a T-shape. I mean, if you have watched my revision class, I'll be like solving most of the questions using this T-shape. So I'll be assuming this has higher potential. Net outgoing current must be equals to net incoming current, that is 0. X minus 0 by 100 plus X minus 1 by 100 plus X minus 4 by 100 is equals to 0. From there I'll be getting the value of X. Once I get the value of X, I'll be putting it in the figure so that I can see it much easily. Potential here is 5 by 3. Now what they are asking, what will the other ammeter read? So potential difference by resistance, 5 by 3 minus 1 by 100, which will be 6.67 milliampere. If the sound heard by observer whose equation is given as y equals to 8 sin 10 pi t cos 200 pi t at x equal to 0, the number of beats. You must have seen, like, when two waves propagating in the same direction with slight change in frequency, difference in the frequencies, like when you add those two equations, you will be getting two terms like this, where in one term you will be getting omega 1 minus omega by 2, in the other term you will be getting omega 1 plus omega 2 by 2. X is becoming 0. When x becomes 0, what is going to happen? It looks like something into t plus something into t, something into t. What is that something? In one case it is omega 1 minus omega 2 by 2. In one case it is omega 1 plus omega 2 by 2. So that is, this is omega 1 plus omega 2 by 2. This is omega 1 minus omega 2 by 2. So from there you can find f1 plus f2. You can find the individual values also, but they ask only beat frequency, that is f1 minus f2, which is going to be 10. A metal wire PQ slides on parallel metallic rails having a separation 0.25 meters, each having a negligible resistance. There is a 2 ohm resistor and 10 volt battery as shown in the figure. There is a uniform magnetic field directed into the plane of the paper. Magnitude is 0.5 Tesla. A force of 0.5 Newton to the left is required to keep the slide wire PQ moving with constant speed to the right. With what speed wire PQ is moving? So what all things they mentioned? They mentioned speed is towards right. If you want to maintain constant speed towards right, you need to apply some force in the leftward direction, they are saying, right? And this value is given. Now why we need to apply force? If you look at, if the thing is moving in the rightward direction, magnetic field is into, then V bar cross B bar into DL bar, that is BLB. That EMF will try to drive the current this way, right? Anyway, but if you want to apply the force in this direction, when will that happen? Only when the current is flowing in this way. When the current is flowing in this way, L bar cross B bar, magnetic force will try to pull it in this direction, right? If magnetic force is trying to pull it in this direction, then only you need to apply some force in the backward direction. What does this mean? The meaning of this one is current is flowing in this way. If current is flowing in this way, you can see like 10 volt must be more than BLV, right? Because it is driving current in this direction. So what is net current? Net current is 10 minus this EMF by 2 ohm. That is the current. Now BLV value, B value, L value, when you substitute, you will be getting BLV as V by 8. Now what is going to be force? This force is magnitude wise equals to I into L into B. And this force is given as 0.5 Newton in the question. What about I? How to find I? I is 10 minus V by 8 by resistance. L value is given, B value is given. So from here you need to find only V value. When you solve it, you will be getting V value as 16. The next question, a man of mass 50 kg is running on a plank of mass 150 kg with a speed 8 meters per second relative to the plank as shown in the figure. Both were initially at rest and velocity of the man with respect to ground anyhow remains constant. Plank is placed on smooth horizontal surface. The man is the man while running whistles with a frequency of 0. The detector D is placed on the plank, detects the frequency. Man jumps off with the same velocity from point D and slides on smooth horizontal surface. Assume the coefficient of friction is 0. The speed of sound is 330. Assuming that, you need to find what is the detector frequency detected before jumping and after jumping. So before that, let us see like what are the speeds. So what they said, man is moving with a speed 8 relative to the plank. So let me say if the plank is moving in this direction with V, so his speed is going to be V minus 8 or 8 minus V. Now I can say total momentum must be conserved because there is no horizontal force. So if I conserve total momentum in the horizontal direction, that is 0 initially, I will be getting the value of V as 2. When I get the value of V as 2, I will be just putting it back so that I can see clearly. His speed is 6 with respect to ground and this speed is 2 with respect to ground. Now you can see source is moving towards the detector. Detector speed is how much? Detector speed is 2, source speed is 6. Now this is a simple Doppler's question, right? So you can use 330, yeah, that thing, right? One speed, this speed is 2, this speed is 6. So you can use simple Doppler's effect and you will be getting option A as correct. But when the man jumps off, what is going to happen? Source will be moving in this direction with speed 6 and detector will be moving in this direction with speed 2, right? So that's the difference from first case to second case. In the first case, both are moving towards each other. In the second case, both are moving away from each other, right? In the next question, two coherent point light sources are placed at x equals to minus d by 2 and plus d by 2. These sources are surrounded by a spherical screen having equation x square plus y square plus z square equals to r square. The source emits monochromatic light of wavelength d by 3. Waves from both the sources reach screen and superimpose. When the waves reaching any point on the screen have constant path difference n lambda, it is constructive in nature, that is called as maximum, that you know. So you need to find how many number of maximas will be there. Then which of the following data is correct about the shape and length of the second order maxima? Yes, they said two sources, this distance is d by 2, this distance is d by 2, so the distance between these two sources is d, where d is 3 lambda, given. Now if you want to talk about the path difference here, that is this distance minus this distance, which is d, 3 lambda. So path difference here is going to be 3 lambda, path difference here is going to be 3 lambda. If you want to talk about the path difference here, this length and this length is going to be same. So path difference here is 0, path difference here is 0. So here it is 0, here it is 3 lambda. So I know like somewhere down the line 1 lambda must come and 2 lambda must come, path difference. So 0, 1 lambda, 2 lambda, 3 lambda, 2 lambda, 1 lambda, 0, 1 lambda, 2 lambda, 3 lambda, 3 lambda, 2 lambda, 1 lambda, 0, right? Now they are asking how many constructive fringes will be there, like 1 is, yeah, 3 lambda here, 2 lambda here, right? So how many you can count? 1, 2, 3, 4, 5, 6, 7. Now when you take a circle here, like now this path difference is, yeah, if I take some point here, when I draw like one line and the other line, the path difference is going to be 2 lambda. Now how many such points I can get? I can get infinite number of such points. If I assume like I have connected 2 threads here, and if I rotate it, still the thread length will be same. So I will be getting a circular bright fringe, circular, but here it is points. Now they are asking at what distance this second order maxima will happen and what is the length of that second order maxima. So what I have done is, I have drawn this dotted lines. Now that path, this dotted line length minus this dotted line length is 2 lambda. But when I go with that approximation, what you have done in YDSC, when it makes an angle theta, now you can see like it's like YDSC, right? There are two sources, and if there is some vertical, yeah, I mean when you rotate this, you can see it's like two sources and there is some screen, right? So at that time, what you used to do, you used to take the angle with the center, this thing, right? So if I take that angle as theta, then the path difference is going to be d sin theta, right? When there are sources with the distance between them as d, and when the angle made with the horizontal is theta, then the path difference is going to be approximately d sin theta. So that d sin theta is 2 lambda, so sin theta is 2 by 3. Once I know sin theta is 2 by 3, then this is theta, this is 90 minus theta, I can look at the right angle triangle. So then if I want to find this length, then that is Okay, this is 90 minus theta. So r cos 90 minus theta, this is r sin 90 minus theta. So r cos theta, r cos theta, r cos theta is cos theta, sin theta is this much, so cos theta is root 5 by 3. So r cos theta is root 5 r by 3. So if you want to find the circumference, circumference is going to be 2 pi into that radius, 2 pi into that radius, which will give you option B. So it will be circular 2 pi into radius, 2 pi into radius is root 5 r by 3, right. Going to the next paper, it's like the elastic collision between two bodies A and B can be considered using following model. A and B are free to move along common line without friction. The distance, when the distance is greater than 1, then the interaction force is 0. When the distance is less than d, then there is repulsive force. The mass of the body A is 1 kg and it is initial at rest. Mass of the body B is 3 kg and it is approaching A with speed 2. So they are asking other questions, so we will look into the options later. So this is the initial thing. They said this is approaching this one at a speed 2. Now when the distance between them is more than 1 meter, there won't be any force. Now suppose if it is less than 1 meter, so when it just entered the region where this distance is 1 meter, then what is going to happen? There will be repulsive force on this one, on this one. What is that repulsive force? It is 6 Newton. If the force is 6 Newton, this acceleration is going to be, this is not 2, this is 6. So if the force is 6 Newton, then this acceleration is going to be 2 Newton, this acceleration is going to be 6 Newton, 6 meters per second square, 2 meters per second square, 6 meters per second square. Now that is how it looks from ground frame. But when I go on to center of mass frame is not accelerating because there is no external force. But center of mass has some velocity. What is that velocity? m1 v1 plus m2 v2 by 2. When you do that, you will be getting the center of mass velocity as 1.5 in this direction. So when I observe the same thing from center of mass frame, it looks like this, where the speed is 0.5, where the speed is 1.5. Alright, you can see the momentum is 1.5, 1.5. Net momentum of the system must be 0 in center of mass frame. So this is how it looks in center of mass frame. Now what they are talking about? First option. Okay, first option says the minimum distance between the two is 0.75 meter. 0.75 meter. That is, I am going to see like where it will stop. Where it will stop. It's like this is having velocity this way and acceleration this way. So what will happen? It will travel some distance and it will stop, right? Now this one also will travel some distance and it will stop, right? Now when this stops, immediately this one also will stop because momentum of the system in center of mass frame must be 0 any point of time. So if this is stopping, this one also must stop. So I am calculating what is the distance travel, that is u square by 2a, s equal to ut plus half at square, or v square minus u square equals to 2as you can use, right? So when you use that, you will be getting the distance traveled by this one is 9 by 48, the distance traveled by this one is 1 by 16. So what is the total distance traveled? It is this plus this, which is 0.25. But initially the separation between them is 1 meter and this total distance traveled is 0.5. So what is the remaining? Remaining is 0.75. So the minimum distance between them is 0.75. Now how that looks from ground frame? From ground frame, they will be having same velocities and they will be, okay, we'll see after that. Okay, right now what happened, it came here and it come to rest instantaneously, this came to rest instantaneously. Now after that, what is going to happen? There will be still acceleration in this direction, so it will move this way. This one also will have acceleration in this direction, so it will move this way. So they will be reaching some, again 1 meter. After 1 meter, what will happen? This will go this way and this will go this way in center of mass frame. In center of mass frame, with whatever velocity, with whatever speeds they will be approaching, they will be going with the same speeds finally. Now when you look from ground frame, we will see how it looks. Time taken to get that minimum approach. Time taken from here to here is how much? That is, you can use v equals to u plus at you can use because speed is going to become 0, right? So 2u by a, so that is half. Either you can use the time taken for this one to stop or this one to stop, both must be same. You can see that is half second. Velocity of mb never becomes 0, velocity of ma finally is in the leftward direction. Okay, anyway, so we will look at the situation. Now in center of mass frame, this is coming with speed 0.5, 1.5. So what is going to happen? They are going to come and they are going to come to rest. After that, they will be moving in the backward direction. Now when it reaches the same position, this will be having speed 0.5, this will be having speed 1.5 because it is elastic collision. There is no touching happening, so energy conservation of mechanical energy must be happening. Kinetic energy conservation also will be happening, right? So when I look from center of mass frame, this will be having a speed of, they are coming to rest. When they are coming to rest, it looks like this, but anyway that doesn't matter. Now after coming to rest, still their accelerations are in this direction, so they will be moving away and it will be achieving, okay, what I did, yeah, I mean you don't need this calculation, I just did the calculation, but you can see like this velocity is going to be 0.5 in center of mass frame, this velocity is going to be 1.5. This is coming with 0.5, 1.5. Now after collision, like this will be going with 1.5 and this will be going with 0.5. That is from center of mass frame. But when I look the same thing from ground frame, then the speed will be 1 and the speed will be 3. The speed will be 3. Now throughout this motion, yeah, anyway, we will see about option D. Final velocity of MA. Final velocity of MA. What is A? A is this. Final velocity of MA is 3. Yes, that is correct. Now throughout this, velocity of MB never becomes 0. MB never becomes 0. Is that correct? Yes. Initial speed is 2. Initial speed is 2. Final speed is 1 in the same direction. So what is going to happen? Its speed is reducing and it is becoming 1. It's not becoming 0 at any point of time. Yes, that is correct. In the next question, in the given AC circuit, choose the correct statements: impedance, power factor, peak value of current, and average power supplied. So what you will be doing, will be drawing the phasor. I will be taking current in this one is IL, where inductor is there. This current is IC. Thereafter, I have drawn the phasor diagram by taking the voltage as reference. These two are in parallel, right? So I have taken voltage as reference. So if I take voltage as reference, then the current in the capacitor will be leading the voltage by 90 degrees. Current in the capacitor will be leading the voltage by 90 degrees. And how to get that value? V by XC. I am taking the maximum value, like 100 by 2. 100 by 2 is 50. So maximum value of IC is 50. Now similarly, if I want to draw the phasor of this part, then current in the inductor and voltage in the resistor, they will be in phase. So if I take current in the inductor this way, then voltage in the resistor will be in phase, but voltage in the inductor will be leading by 90 degrees. These two must be perpendicular, right? And the summation of these two voltages must give me source voltage. And what about the thing? The thing is, both are of equal resistance, right? So resistance and inductive reactance, right? So these two must be of same length. So from there I can conclude this angle is 45 degrees, this angle is 45 degrees. It will be making a 90 degrees here, right? Yeah, source voltage is 100. Okay, that is fine. Now, what about V across resistor? It is going to be current into resistance. That is IL into 1. What about this one? IL into 1. So voltage across the resistance is magnitude wise IL. Voltage across the inductance is magnitude wise IL. But I know this plus this vector addition must give me this, right? That is root of IL square plus root of IL square. That is IL root 2. IL root 2 must give me 100. IL root 2 must give me 100. So IL is 50 root 2. 50 root 2. I have put IL is 50 root 2 thereafter, right? And yes, IC value I have put 50. Now what we need to find? We need to find impedance. So if you want to find impedance, what you need to see? You need to see what is the total current. Total current into impedance will give me source voltage, right? Now total current is how much? How to calculate that? That is vector addition of these two. Now this is 50 root 2. Now when I resolve it, I will be getting vertical component is 50 and horizontal component is 50. So this vertical component and this vertical component will get cancelled. So equivalent current is going to be 50 ampere, and that is in phase with source voltage. Right? Maximum value is 50 ampere. So maximum current into Z equals to maximum voltage, source voltage, that is 50 into Z equals to 100. So from that Z is 2. Impedance is 2, option A is correct. Power factor is 1 by root 2, no, it is wrong, because the net current is in phase with the source voltage. So power factor is 1. Peak value of current through resistance. Through resistance, what is the current? IL. So what is the peak value? Peak value is 50 root 2. That is correct. Now the last option, average power supplied by the source. Average power is Vrms into Irms into cos phi. V maximum is 100, so Vrms will be 100 by root 2. I maximum is 50. Resultant of these two is 50, right? I maximum is 50, so Irms will be 50 by root 2. And what is the power factor? Power factor is 1. So that will give you option D as correct. The next question, two circular rings of radius A having resistance per unit length lambda are moving with a uniform speed V along x-axis as shown in the figure. Magnetic field is into the board. The separation between the centers is just greater than 2a. So initially the circles are just touching, right? Just greater than 2a. Now they are crossing one on the another. Force on any circular ring at time t and current in BDA. Okay, we can find current in BDA first. So what is going to happen? Okay, let me show you the figure. So magnetic field is into, so when a loop is moving, okay, if I want to find what is the EMF induced in this part of the circle, then I can take the effective length, right? It's like V bar cross B bar. So the magnitude will be like V bar cross B bar dot DL bar, or like VB into this length, VB into this length. What is this length? This length is going to be A according to the given information, right? So this is 60 degrees. If this is 60 degrees, now these two must be same angle, so that will turn out to be 60 degrees. So all the lengths will be A, all the lengths will be A. That you can manage. Now all you need to understand is, if I want to find the induced EMF in this part, I can take effective length. If I want to find the induced EMF in this part, I can take the effective length. If I want to find the induced EMF in this part, I can take the effective length. If I want to find the induced EMF in this part, I can take the effective length, right? Now what about the direction? It's like, if I take effective length of this part, then V bar cross B bar. So induced current will try to drive this way, so that is this way. Now if I take this part is moving this way, so V bar cross B bar, so it is trying to drive the current this way. So the net current, if I take some closer path like this, then the net induced EMF must be 0. So in this one it will be trying to drive this way, in this one it will be trying to drive this way. Anyway, that you people must be knowing. Now similarly on this one, this is moving with the speed this way, so V bar cross B bar, so it is trying to drive the current this way. Now V bar cross B bar, it will be trying to drive the current this way. Now in all the four things, induced EMFs magnitude wise it will be same. Now direction wise, this will try to drive the current this way, this one this way, and this way. Now what about the resistance? Resistance value depends on the length, right? Now this length is 1/6 and the remaining length is 5/6, right? So if this resistance is R, I can call the remaining resistance as 5R. If this resistance is R, then this is 5R, right? Now that's the circuit. Now you can see like circuit. When I try to redraw it, it looks like this. The red color one as it is, the blue color one as it is. Okay, I have calculated like resistances also, that you can manage. That's not a problem. Now if I want to find the current, what I did here is, again I went with the same principle. I assumed this potential as 0, 0, 0, 0, 0. If this potential is 0, then this potential is going to be E, minus E, plus E, and minus E. Now I can see T shape again, so I will be assuming this potential as X, and net outgoing current must be equals to net incoming current. So X minus E by 5R plus X minus X plus E by R plus X minus E by R plus X plus E by 5R equals to 0. From there, when I calculate, X value will turn out to be 0. So if this potential is 0, then I am calling the current in this one is, I can see like this is higher potential, this lower potential. So current will flow from higher to lower. So I am assuming this current is I. If this current is I, then this is 5I, this is 5I, this is I, and the directions are like from higher to lower and stuff. Now anyway, what we need? We need to find the current in BDA, which is BDA. Current in BDA is current in the last one. That is E minus 0 by 5R. E minus 0 by 5R. What is E? E is BLV, where effective length is A. BLV by 5 times of radius, 5 times of resistance R. Resistance R is lambda into pi A by 3. So when you substitute, you will be getting option C as correct, option D as wrong. But if they are asking what is the force on any one loop, now you can see in this loop the current is going this way. So that is, again, if I want to find the force, I can again go with the effective length. So that is L bar cross B bar. The direction is this way. What about this one? Current is going this way. Again, L bar cross B bar. So force on this element and this element are going to be in the same direction. So I can add them. Right? Force on one element, force on the other element. ILB. Now effective length is same. The only difference is current. In this one current is 5I. In this one current is I. Current is 5I, current is I. So 5I into A into B, I into A into B. So the net force is going to be 6 times of I into A into B. I value you got from, you can get the I value, right? E minus, E by 5R. So when you substitute, you will be getting option B as correct and option A as wrong. Going to the next question, 3 positive charges each of magnitude Q held at vertices of an equilateral triangle ABC with sides A as shown. The point P1 is the point where net electric field due to all charges are 0, that is at the centroid. E1A, E1B and E1C are the magnitude of electric fields at point P1 due to charges A, B and C respectively. As we know that there will be another point on the y-axis where net electric field due to all charges is 0. Say this point is P2. E2A, E2B and E2C are the magnitude of electric fields at point P2 due to charges A, B and C. So yes, in order to solve this question, you need to understand this thing. You can look at this question, like at centroid the field is going to be 0 by symmetry. Now you need to see like what will happen to the force just below it, So if you want to find the force just below it, what you need to do, you need to find the force because of this B and this C, which looks like, the equation looks like a rings force equation, rings field equation, right? So what will be the force or what will be the field there? Yeah, if you take a point charge here, if you displace it, and if you find the force on it, then force because of BC is going to be this much, that is in the upward direction, and force because of A is going to be this much, that is in the downward direction. Now where the displacement is small delta, right? Now when you calculate the net, when delta is very very small, when you calculate the net is going to be positive value. The meaning is the force because of these two charges is going to dominate the force because of this charge. Now you can see here the force is 0, but when you displace it slightly, what is going to happen? Force because of these two is in the upward direction. So force here is 0, just below it force is in the upward direction, but when you come along this direction, you can see here at this point force because of B and C is going to be 0, force because of A is going to be in the downward direction. Now field won't vary like suddenly unless the charge is appearing on the line. There is no charge here, right? So the field is going to vary continuously. What you can see, field is 0, force is 0, after that force is in the upward direction. Now finally it is going to be in the downward direction. So somewhere down the line it must have become 0. Right? So now that's the conclusion. After understanding like somewhere down the line it will become 0, you can understand field can become 0 here also. Now similar such point 1, 2, 3. Like on this line also it can happen, right? On this line also it can happen. Now that's the thing. Now from here what they are talking about, first option is E1A, so that is field here is greater than E2A, field here, no, yes, yeah, so field because of A at point 1 is greater than field at point 2 because of A, that is correct. Field at 1 because of B, is greater than field at 2 because of B. No, because this distance is more, this distance is less. So field at second point is more. So option A is wrong because of that reason. What about option B? Field at point 1 because of A, is greater than, yes, that we have already seen. Field at point 1 because of C, is less than field at point 2. Yes, that's correct, because this distance is less, so this field will be more. Option B is correct. Now what about option C? Yeah, option C, yeah, we have already seen, right? Electric field because of B at 1 is greater than at 2. No, it will be greater at 2. Now what about last option? It is field at point 1 because of B is less than at 2. Yes, that is correct, because at 2 the distance is less, so field will be more. Field due to C at point 1, is less than field due to C at point 2. Yes, this distance is less, so the field will be more. So option D is also correct. The key of the circuit has been kept open and at certain moment it is closed. Before closing the switch, capacitor has no charge and inductor has no current. Ammeter is ideal. The reading of ammeter immediately after closing the switch. Yeah, immediately after closing the switch. How it is going to look immediately after closing the switch? Immediately after closing the switch, this circuit is going to look like this, right? Inductor won't change the current in it suddenly, so it will behave like open circuit, this will behave like short circuit. Now what they are asking, the reading of ammeter immediately just after closing the switch. Now at this moment, yeah, this equivalent resistance is going to be 0, no current will flow through this. Now what is the equivalent resistance? Equivalent resistance is going to be 0 plus 4R, which is 4R. So what is going to be the current? Current is going to be V by 4R. But what will happen to that current? That current will be flowing through this part only, because no current will flow through this resistor. So ammeter will show 0 reading. Now what about the next case? When key is kept closed until a steady state is achieved, then key is opened. So until a steady state is achieved, so once the steady state is achieved, what will happen, this will behave like open and this will behave like short. So what will be the current? Current is going to be V by R, V by R, V by R. Now when you are opening, what will happen? Current in the inductor won't change suddenly, it will still remain V by R only, right? Yeah, I think you can see that here. So after steady state is achieved, this will behave like short circuit and no current will flow through this one, and current will be V by R and stuff. Now when you are opening this again, what will happen? This capacitor which was charged, it will act like a battery at that moment. Now apart from that, what I can say, current in the inductor won't be changing suddenly. Now these two things I know. So I assumed this potential as 0, this potential will be 0. Now if this potential is 0, this potential has to be V, because that I can get from here. Now the thing is, if this current is V by R, then when I go with KCL, I can say this current is also V by R. Now I can see resistance, I know current, so I can find the potential difference. Potential difference is 4V, and if this potential is V, this potential has to be minus 3V. If this potential is minus 3V, then this potential also will be minus 3V. Then if this potential is V, then this potential also has to be V, because it is ideal ammeter, right? Yes, I think by using KCL, I can figure out like this potential difference is V, right? V minus 0. So this current is also going to be V by R. This current is V by R because current in the inductor won't change suddenly. This current is V by R because the potential difference is V. Now if I know these two currents are V by R, what I can say? I can say current in the ammeter is going to be 0, because incoming current is equals to outgoing current. So current in the ammeter is going to be 0 in both the cases. In the next question, a thin film of liquid of surface tension T is formed between smooth fixed vertical rectangular frame and a quarter circular wire AB of mass m and radius r. The end of A of wire AB is hinged. A vertical upward force F is applied at the end of B to keep it in equilibrium. So choose the correct options. The magnitude of force required and the torque due to. Okay, so we'll go with option D, the force of surface tension, then we'll go with option C, then we'll go with option A or B. Now, if I draw the FPD, it looks like this. The surface tension force will be acting perpendicular to that small length every time, right? But what I know, if I want to find the force, apart from surface tension force, there is some force F we are applying, and hinge force will be there. Hinge force I have taken like one x component, one y component, right? Now, if I want to find what is the force, we have already seen like I can go with effective length. I can visualize it like instead of this one, there is effective length, right? So now if there is effective length, then if you want to find the surface tension force, that is surface tension times effective length, right? That is if one interface is there. But how many interfaces are there? When I am going from this side to this side, like I will be going from air to soap film and soap film to air. So there are two interfaces. So there will be T into L 2 times, right? Now what is the effective length? Effective length is going to be R and R. So this is root 2R. So force is going to be T into root 2R if there is one interface, but there are two interfaces, so 2 times of T into root 2R. Now what about the direction? The direction is going to be this way, which is making angle 45 degrees, that is minus I cap plus j cap by root 2. The direction is minus I cap plus j cap by root 2, right? So when you substitute the values, you will be getting the answer as D, surface tension force, magnitude wise. Now, yeah, the surface tension force is in this direction. Now if I resolve it horizontally and vertically, you can see horizontally it is going to be 2Tr and vertically it is going to be 2Tr. Now this net horizontal force must be 0, so this 2Tr must be cancelled by x. So x equals to 2Tr. Now what about y? Y plus 2Tr must be, y plus 2Tr plus F, all are in the upward direction, that must be balanced by weight. Now this is a semicircular, it is a quarter, right? So the center of mass will be somewhere here. Where this vertical distance is 2r by pi. So this distance I can calculate easily if I need, right? So x plus 2Tr plus F equals to mg. So from there I will be getting y value as mg minus F minus 2r. Anyway, do we need that? I think we don't need that exactly. Okay, now they are asking what is the torque because of surface tension about this point. Now there is one important property I am going to use. Like suppose there is a there is this strip already. Now suppose there is some straight wire also. Suppose there is some straight wire also where the force is this way. Now the net force because of, okay, yeah, I can see, maybe let me say there is a straight wire on which the forces are in the opposite direction. Then what is going to happen? Net force on this one plus this one is going to become 0. Now if the forces become 0, then the torque because of those forces doesn't depend on about which point I will be calculating. So if I calculate torque about this point, then torque because of all these forces will become 0 because they will be passing through the center. Now torque because of all these forces will become 0 by symmetry, because some of these forces will be trying to rotate this way, some of these forces will try to rotate this way. So what I understood, if I take some element, if I take some strip like this and if I apply forces like this, then the net force is going to become 0 and their torque about this point is going to be 0. If the force is going to become 0 and if the torque about this point is going to become 0, then the torque about any point because of those forces must become 0. So if I want to take the torque about this point, then torque because of these forces will be same as torque because of these forces. So I will be indirectly calculating it. So instead of finding torque because of these forces, I will be calculating torque because of these forces which are applied in the opposite direction. Magnitude wise they will be remaining same. Right? Now if I want to find the torque because of these forces, then what I can do, at a distance x I can find the force and I can write the torque equation, that is x into force there. Force on this element is T into dx if there is one interface, but there are two interfaces. So this is the torque on element, and if I integrate from 0 to 2r, I will be getting the total torque. That will give you option C. Now apart from that, what you need to find? You need to find magnitude of force F. So the better option is I can take torque about this point, because y value calculation is hard, right? X value we found, but y value like unnecessarily we need to do them. So when we take torque about this point, that torque must be 0, that is torque because of surface tension force which will try to rotate it this way, and torque because of weight which will try to rotate it this way, torque because of this force which will try to rotate it this way. So this force will be applying how much torque, that is perpendicular distance is r times force in this direction. Now this surface tension will try to rotate it, this way, whose value we calculated it already, 2t into r square. This force and this surface tension force, they are trying to rotate in the same direction. Now apart from that, weight will act at the center of mass, that is perpendicular distance. This is 2r by pi, this is r minus 2r by pi into mg, So when you calculate from there the value of F, you will get option B as correct, option A as wrong. Two samples of ideal gas of the same amount are taken through cyclic process, half of rectangular in shape as shown in the figure. The figure shows PV diagram of the process 1231 and 1341. If the working substance of two engines if the efficiency of cycle in process 1 is 20%, find the efficiency in the second process. So what I did here is, I just, for my convenience, I assumed this pressure as P, V, and this temperature is T. Now I assumed this pressure is alpha P, so the temperature is going to be alpha T. Now and this volume I assumed it as beta V, so this temperature is going to be beta T, and this temperature is going to be alpha into beta into T. Anyway, that's not needed. So I can see the temperature is increasing, so gas will be taking the heat. Here also I can see temperature is increasing, so gas will be taking heat, so plus. Here gas will be releasing the heat, so minus Q3. Here also gas will be releasing, so minus Q4. From here to here it will be taking, so plus Q. From here to here it will be giving, so minus Q. The same minus Q, plus Q and minus Q, right? Now what I did, like in a cyclic process, change in internal energy will be 0. So if I want to calculate work done, I can say it is Q1 plus Q2 minus Q. Or in this one I can say Q minus Q3 minus Q4. So I can say this area is same as this area, or like Q1 plus Q2 minus Q must be same as Q minus Q3 minus Q4, which is work done in both the cases, right? Now efficiency in the first case will be work done in the first case, Q1 plus Q2 minus Q by total heat given, that is Q1 plus Q2. In the second case it is total work done Q minus Q3 minus Q4 by only heat given plus Q. Now this I can write it as W, and what about Q1 plus Q2? Q1 plus Q2 I can write it as W plus Q. Now similarly this I can write it as W, this is Q. Now when I modify it, I will be getting something like this, but Q by W I can write it as 1 by eta 2. So from there I will be getting 1 by eta 1 plus 1 by eta 1 equals to 1 plus 1 by eta 2. So from there, after substituting, you will be getting the required answer. A moving hydrogen atom makes perfectly inelastic collision with stationary Li++ ion. Just before collision, both hydrogen and lithium are in the first excited state. Immediately after collision, hydrogen was found to be in ground state and lithium was in second excited state. Find the kinetic energy of hydrogen atom before collision. Now, in perfectly inelastic collision, what is the kinetic energy loss? Kinetic energy loss will be half m1 m2 by m1 plus m2 into relative velocity square. Relative velocity square. Now, this is the loss in kinetic energy. Where will this kinetic energy go? We will see that. Now, what they said, initially hydrogen is in first excited state and lithium plus is also in first excited state. So, what is the energy of hydrogen initially? It is this much. What is the energy of, we want to find the difference in the energies. So, I am just calculating. So, this is the energy of the lithium in the initial state. Now, finally, hydrogen is in the ground state and lithium went to the second excited state. Now, what is the difference? What is the difference? The difference is going to be 6.8. It's like I just calculated the magnitude, but initially it will be negative 3.34, right? Negative 27. So, how much energy is needed for that to happen? How much energy is needed? It's like this is minus 34, this is minus 27.2. So, finally it's minus 27.2, initially is minus 34. So, minus 27.2 minus of minus 34, that will give me 6.8. That is 6.8 electron volt has to be supplied for that to happen. Now, from where that 6.8 electron volt will be coming into picture, that is because of the kinetic energy loss. Kinetic energy loss must provide that 6.8 electron volt. So, from there you will be getting kinetic energy of hydrogen initially is 7.77, and they said like mass of lithium you can take it as approximately 7 times of hydrogen. Two identical uniform rods are attached to each other with a pivot joint at their ends. The rods are at rest on a frictionless horizontal top lying on a straight line. Suddenly the free end of the rods is hit perpendicularly such that the end point of the rod begins to move with speed 1. At what speed does the free end of the other rod begins to move? So, this is the figure. It's like there is one rod, there is other rod, they are tied here, but I have just drawn them separately. You are hitting it here and the speed is going to become 1, they said. Now, I am going to say like what are the things I have taken. I have taken this velocity is v1 and this omega 1, and this velocity is v2 and this angular velocity is omega 2. Why I have taken that is because of this impulse. This I am applying. Now, when I am applying it will try to rotate, and I assumed like because of the hinge, the impulse is going to be in this direction on this rod. So, by reaction on this one it will be in the upward direction. Now, if this velocity is v1 and angular velocity is omega 1, then this point's velocity will be v1 plus L by 2 into omega 1. This velocity is going to be v1 minus L by 2 into omega 1. This velocity is going to be v2 plus L by 2 into omega 2. This velocity is going to be v2 minus L by 2 into omega 2. Now, I know these two are tied with a pivot, right? So, this velocity must be equal to this velocity, that is one constraint, and this one they have given it as 1. Now, what I have done is I have written impulse equals to change in momentum. What is the net impulse? Capital J minus small j. Impulse equals to change in momentum, that is mv1. Now, similarly, angular impulse is L by 2 times of j, and this also acting in the same direction. So, angular impulse equals to change in angular momentum. Now, similarly for this one, impulse equals to change in momentum, angular impulse equals to change in angular momentum. So, these are the equations I have written because number of variables look more for me. So, I had to go with this thing instead of conservation of angular momentum about this point. When I do that, I will be getting only one equation, but when I write it this way, I will be getting 4 equations, though the number of unknowns like I am bringing are 2 extra. Though I am bringing 2 number of unknowns, I am getting 4 equations, so that is much better, right? Now, solving this, I have taken this as reference and I found v1 from here, omega 1 from here, v2 from here and omega 2 from here, and I just substituted it back so that I got a relation. I got a relation between small j and capital J. Now, after that what I did, I just substituted it back there. So, v1 plus L by 2 omega 1 is 1 given. So, I just substituted like v1 is j minus j by m, and omega 1 is L by 2 omega 1, that you can find from here, right. So, when I substituted, I got this relation, but I know they are related like this. So, I just substituted it back to get capital J by m is 2 by 7, small j by m is minus 1 by 14. What does that mean? We assumed the direction is this way, but it is going to be in the opposite direction. Anyway, that does not matter. What we need to find, what is the speed of this point, that is v2 minus L by 2 omega 2. So, v2 value is j by m I can find it. Now similarly L by 2 omega I can find it. So the difference is going to be 1 by 7, 1 by 7, which is almost 0.14. So the next question, in the given circuit, EMF of the battery is 10 volt and internal resistance is 0.5 ohm. If a variable resistance R is chosen such that the rate of chemical energy consumed by the battery is maximum. Find the maximum value in what? So, I mean, they have given some repetition. So, generally when there is repetition, what we will be doing, we will be assuming this as x and this thing as also x. But anyway, for this question it does not matter, because if I assume this as x, the equivalent resistance, anyway, they are asking, yeah, the equivalent resistance I am calling it as y. Now they are saying what is the maximum rate at which this chemical energy will be utilized, right? So for that, current has to be maximum. If the current has to be maximum, the total resistance has to be minimum, that is this value has to be 0. How can y value become 0? When this changing value I can put it as 0, then no current will flow through this, it goes only like this, right? So for current to be maximum, y value has to be 0. So if y value is 0, you can find what is the current. Current is E by 1, 0.5 plus 0.5. So EMF of the battery into current in the battery, current given by the battery, that will give you the answer. The next question, a particle of mass 2m collides elastically with a stationary particle of mass m. The maximum angle through which the striking particle may deviate after collision. Now this one also, I think similar example was taken in revision class. In ground frame it looks like this. I will be finding the velocity of center of mass and I will be observing from center of mass frame. In center of mass frame, net momentum will be 0. Net momentum will be 0. After collision, it depends. If it is head on, they will be like going this way. But if it is at some angle, then this will be going in this direction with 2v by 3 and this will be going in this direction with u by 3. So there are many possibilities. Now out of these possibilities, what is the possibility where the maximum deflection will happen for the initial one, right? So that is this it can go in any direction. It can go u by 3 in this direction or in this direction, in any direction. Now if I look from ground frame, this actual velocity is going to be velocity of center of mass, that is 2u by 3 plus velocity about center of mass. Velocity about center of mass will be u by 3 in any possible direction, but which will give you maximum deflection, that is going to be this angle where it will be making a tangent, right? So velocity of center of mass and velocity with respect to center of mass. So that angle is going to be how much? That is sine alpha equals to opposite by hypotenuse. The question was there in revision class also. This is the question and this was the explanation. Maybe if you want, you can watch there. The next question, a uniform circular ring of mass m and radius 10 cm is placed on smooth horizontal surface. An insect of mass m sitting initially on the circumference of the ring starts moving with a velocity 2 relative to the ring along its circumference. Find the angular velocity of the ring about its center. So what I can see here is, if an insect is moving, it will be applying friction on the ring in this direction. So ring center of mass will be moving in this direction. Apart from that, torque also will be there. So like ring will be gaining angular velocity also. Ring center of mass will be moving some velocity and it will be gaining angular velocity also. But I know net center of mass of the system is going to remain fixed because all are internal forces. So the net center of mass will be at a distance r by 3 and 2r by 3, that you can calculate easily. Now what I did, I can do momentum conservation, I can do angular momentum conservation. So by momentum conservation, I can say like this m into v equals to, this mass into momentum. So what I did, I just went with upward momentum equals to downward momentum. Upward momentum is m into v plus m by 2 into v plus r omega, because downward momentum is m by 2 into 2. This 2 is with respect to ring. So it will be having ring's velocity at this point, that is v plus r omega and extra 2. So from there I will be getting relation between v and r omega, but I need to get one more equation. So what is that one more equation? By conserving angular momentum. What was the initial angular momentum of the system? 0. Final angular momentum also must be 0. Now angular momentum of this mass, angular momentum of the ring is going to be angular momentum of center of mass and about center of mass. Now of center of mass will be r by 3 into mv, that is in this direction, I am taking it as positive. And what about this I into omega, that is mr square into omega, that is negative. Angular momentum of center of mass and about center of mass for a ring. And angular momentum of insect, I am taking in this direction, that is negative, right? So this direction I am taking it as positive. Angular momentum of center of mass is positive, angular momentum about center of mass is negative, angular momentum of the insect is also negative. So positive, negative, negative equals to 0. So when I do that, it turned out to be simple that V is not coming into picture, V is getting cancelled. So from there I can get the value of omega, which is 5. A point source of light 0.4 watt, that is 0.4 joules per second, emitting mono energetic photons of energy 5 electron volt, is placed at a distance 50 centimeter from the center of uncharged fixed metallic sphere of radius 30 centimeter and work function 3 electron volt. The efficiency of photoelectron emission is 1 in 10 power 6 incident photons. Assume that the sphere is isolated and the photoelectrons are instantly swept after the emission. The time from the beginning of the experiment after which the photoelectron emission will stop. Now what is going to happen? Electron will be emitted. Once the electron is emitted, this will become slightly positive, and further electron will be emitted, so it will keep on becoming positive. At certain point of time, what will happen? Whatever the electron coming out, it will have some kinetic energy, but it is becoming like positive charged sphere, right? So what is going to happen? When the electron is going away, then that positive charged sphere will try to reduce its speed and try to pull it back. That is, it can't escape to infinity. So whatever kinetic energy is there, that kinetic energy plus potential energy must be equals to 0. Then it won't reach infinity. Before reaching infinity, it will come to rest and it will come back. So magnitude wise kinetic energy and potential energy must be same. That is, kinetic energy plus potential energy has to be 0. So potential energy will be negative, obviously, because electron is negative charge and the sphere is positive charge. So magnitude wise they must be equal. So that's the thing I will be working on. Now the first thing is, this will be emitting photons in all the direction, but only partially they will be falling here, right? These photons won't fall here. Now how much of that percentage will fall? Now it looks like if there is a point charge and if I want to find the flux through a disk here, then it is q by 2 epsilon naught into 1 minus cos theta. That is q by epsilon naught into 1 minus cos theta by 2. That is, out of the total flux, 1 minus cos theta by 2 will fall on the disk. I will be going with the same example. If the power is P, 1 minus cos theta by 2 will fall on this region, So power is 0.4. Out of that, 1 minus cos theta by 2 will fall on that region. That is 0.04 watt will be falling on that region. That is 0.04 joules will be falling on that in 1 second. So now before that, like, what is the thing we need to find? We need to find out of 5 volt, like 3 volt is the threshold thing. So the kinetic energy of the electron which will be coming out will be 2 electron volt. So when that kinetic energy will be equal to potential energy magnitude wise, then it won't be escaping to infinity, right? So what must be the charge of the sphere? Charge of the sphere has to be 2 times of radius by k. Now we need to see after how much time this charge will be available on the sphere. That is our aim. For that aim, what we have seen like how much power is falling on that sphere. Now if this much power is falling on that sphere, how many photons will be there? For each photon the energy is this much. So in this much energy, how many photons will be there? 5 into 10 power 16 photons will be there. Out of these many photons, all won't be ejecting electrons. Only like 1 by 10 power 6 photons will be out of these photons, only 1 by 10 power 6 will be emitting electrons. So how many electrons will be emitted in 1 second? These many electrons. But how many electrons are needed to get this much charge? We will see. This many electrons. So this many electrons in 1 second. This many electrons in 1 second. So that is this much charge in 1 second. This much charge in 1 second. But you need to see after how much time. Right? So this many electrons in 1 second. Electrons in 1 second times of, this much charge in 1 second. This much charge in 1 second into time taken will give us charge, right? Now what is that charge? 2 into r by k. After how much time it will become that charge, they said. So from there you can calculate what is the time taken. A stationary tube of length and radius r carries a steady flow of viscous liquid of density rho and viscosity eta. The flow velocity varies with initial radial distance, the pressure difference at the ends of the tube. So you can draw the free body diagram of this part of the liquid, and you can see, if you draw the free body diagram, then there is a pressure difference, right? So the pressure difference force is going to be pressure difference into pi r square. Here P1 into pi r square, P2 into pi r square. So effectively it is delta pressure difference into pi r square. But if net force is there, it will be accelerating. It is not accelerating, we know. So what does that mean? That force will be exactly cancelled with the viscous force. Now how to find the viscous force? Eta A into dV by dz, dV by dr, right? dV by dr. So V they gave, dV by dr you can find. So eta A, what is the area of that cylinder? 2 pi r into L, surface area, right? into dV by dr magnitude wise. So when you substitute, you will be getting the required answer. So drawing the FPD and making the net force 0. The next question, for an ideal gas process, PV diagram is a circle, and adiabatic process from A to C. A to C is adiabatic, A to B is isothermal. So from A to C, what is the heat given? From B to C, what is the heat given? So A to B is isothermal, they said. So A to B whether heat given is positive or negative, that we need to see. So what I have taken this closed path, A to B plus B to A. Sorry. Okay, I think they are talking about A to C. In first option is A to C, right? Yeah, A to C. So I am going with A to C. This is isothermal, so I have just put the same temperature for my understanding, but they are asking from A to C. A to C. So what I have taken A to C plus C to A. Now, when it is a cyclic process, change in internal energy is 0. But what is the work done? This work done is positive, this work done is negative, but effectively the work done will be this area which is positive. So work done is positive. And for a cycle also, I know like Q equals to U plus W, but the change in internal energy is 0. So whatever work done, that will be same as heat, right? Now work done for this total cycle is positive, and I know Q is 0 in this process. So the total Q is positive and Q is 0 in this process, so Q must be positive in this process, right? It's like when I take this closed path, work done is positive, so Q will be positive, and Q is 0 in this path, so Q must be positive in that path. So from there I can get Q has to be positive from A to C. Now B to C, when you look at B to C, like before going to B to C, let me see from A to C. When I go from A to C, work done is positive because volume is increasing, work done is positive and Q is 0. If work done is positive and Q is 0, what is going to happen for change in internal energy? It is going to be negative because work done plus change in internal energy must be 0. So if work done is positive and Q is 0, then delta U is negative. The meaning is temperature is going to reduce. So the small t is less than capital T. Now if I go from B to C, what is happening? Temperature is reducing. So delta U is negative. What is happening to the volume? Volume is also reducing. So work done is also negative. So when these two are negative, I can say Q is also negative. But I am not getting from like C to D how to get it exactly. The next question, column 1 gives a situation in which two dipoles of dipole moment I cap, P I cap and root 3 P J cap are placed at origin. A circle of radius r with center at origin is drawn as shown. You need to match. So what will be the net dipole moment? Net dipole moment will be vector summation of these two. So that is going to be 2p along this direction, which will be making an angle 60 degrees. So this coordinates is going to be r by 2, root 3 r by 2. Now similarly this is minus r by 2 minus root 3 r by 2. Now perpendicular to it, it will be root 3 r by 2 minus r by 2. These coordinates you can get it. This is along the dipole and this is perpendicular to the dipole. Now potential is maximum. Okay, so from there you can get everything easily, right? So potential is Kp cos theta by r square. So cos theta, that is when theta is 0, potential will be maximum here, right? So for which point r by 2 comma root 3 r by 2, so p is 1, that is fine. Now coordinates of point on the circle where the potential is 0, where the potential will be 0 when theta is 90 or this 90 or this 90, that doesn't matter much, right? So potential here and here will be 0, that is root 3 r by 2 and minus root 3 r by 2. So that is 3 and 4, okay. Now what about the next one? Coordinates where the electric field is 4p, that is 2 times of this dipole moment is 2p, so 2 times of Kp by r cube, K dipole moment. So 2 times it is going to happen here and here magnitude wise, right? So that is r by 2 comma minus r by 2 thing, which is 1 and 2, options 1 and 2. Yes. Thereafter the next question is where it will look like Kp by r cube form. Here it will look like Kp by r cube here, that is 3 and 4, right? That's a simple question. The whole motion is on smooth horizontal plane, parallel conducting bars are infinitely large and vertical uniform magnetic field, finite mass and resistance less wires and stuff. So so in the first question I can say no current will be flowing, right? There will be just induced EMF, but no current will be flowing, so it will keep on moving with the same velocity. So from there I can say uniform motion, yes it's correct. Uniform accelerated motion, no it's wrong. Non-uniform accelerated motion, no, it's wrong. Velocity of the rod is non-zero constant. Yeah, it will be moving with the same speed. No opposing force, right? No, same speed. Motion is SHM, which is wrong. So first one is okay. Now going to the second option. Now PQR, okay, uniform motion is going to be wrong because I know like there will be power dissipated here, right? That I guessed. I mean, we kind of manage it, like it won't move with a uniform speed because this kinetic energy will be converted as heat energy here. Anyway, so uniformly deaccelerated motion. Uniformly deaccelerated, that I am not sure, but we can look onto that. But I think it is going to stop after that. There won't be any acceleration. So anyway, we can look onto that with the equation. Now going to the third option. Yeah, Q and R are like related things. Velocity of the rod after a long time is non-zero constant. No, it is zero. It is not performing SHM. Now when I write the force equation, like when it is having some velocity v, then current will be driven this way. If the current is driven this way, so L bar cross B bar, I into L into B, force is going to be this way and opposing, right? Opposing the velocity. ILB equals to mass times of acceleration. Now I will be BLV by R, potential difference by R. So from there you will be getting acceleration is of the form something into V form, but in the opposite direction. If the velocity is this way and acceleration is in the form K into V, it's like a friction, right? It's like friction whose, air resistance or like viscous force thing. What is going to happen? If only resistance force is there, what will happen? It is going to stop after some time. Yes, and it is, when you do the integration, it will turn out to be like acceleration is non-uniform also. So from there I can get option R as correct and option Q as wrong. Now similarly going to the next question, I can write the force equation. Now F minus ILB. Now when it is going this way, it will be trying to drive the current this way. Okay, fine. So there will be opposing force. So net force is going to be F minus ILB. F minus ILB equals to mass times of acceleration. But how to find this? This I is varying, right? So Q equals to potential difference into C into potential difference. Q equals to CV, right? Q into potential. Q equals to C into potential difference. Now if I differentiate this, I will be getting current is equals to CBLA. So when I substitute that current back, I will be getting two acceleration terms. When I take them common, then I will be getting acceleration as constant. So from there I can get option Q as correct, remaining as wrong. If acceleration is constant, then it is going to keep on moving. Now similarly for the next one, again opposing force equals to mass times of acceleration, but if I want to find the current, that is E minus BLV by R. So when I substitute it back, I will be getting this equation. This equation looks like acceleration equals to some constant force minus some constant minus K into V form. Now this kind of thing you have seen in terminal velocity. That's like when there is gravity plus buoyancy, which is constant force, and there is viscous force in the upward direction. Viscous force varies with velocity and constant force is downwards. Now what is going to happen? After some time it is going to achieve terminal velocity. So non-uniform acceleration, and it is going to achieve terminal velocity. So option S is also correct. None of them performs SHM. Figure shows a string at certain moment. Oh, okay. So you need to match the following: velocity of A and acceleration of A, velocity of B and acceleration velocity of C. So if the wave is moving forward, in the next moment it is going to look like this. So A is going downwards. A is going downwards. B is So when you look at the options say velocity of A is downwards if the wave is traveling towards right, velocity of A is downwards. Yes, velocity of B is in the upward direction, right? It is going in the upward direction. So okay, anyway, at that moment like velocity will be there, right? So it is going in the upward direction. All you need to do is just plot the wave in the next moment. Now you can see like particle A, this particle will be moving along this direction, so it has went down. This particle will be moving along this direction, so it has went up. This particle will be moving along this direction, right? So but velocity of C is going to be 0 because it is at the extreme position. So velocity of C is 0, velocity of B is in the upward direction, velocity of A is in the downward direction. Now what about acceleration? Acceleration of A. So it will be performing SHM, right? So when it is displaced in the upward direction, acceleration is going to be in the downward direction. Acceleration is going to be in the downward direction. Now if the wave is moving towards left, then A is going in the upward direction, A is going in the upward direction, B is going in the downward direction, and what about C? Speed of C is 0 anyway. I mean speed of C is 0 anyway. But what about the acceleration? Acceleration of A. Acceleration of A, it is in the upward direction. It is displaced in the upward direction, so acceleration will be in the downward direction. Acceleration of A is in the downward direction. Velocity of B is in the downward direction. Now when you combine those two results, only option B, that is acceleration is going to be in the downward direction no matter what it is. Acceleration of particle A, whether the wave is going in the forward direction or backward direction, is going to be in the downward direction, right? Yes, thank you.